Here we are given this function f of x equal to x square sine 1 by x when x is less than 0 and root x when x is greater than 0. Then we have to find this limit 0 plus f of x. Okay, so 0 plus means we are moving from the right hand side. Okay, 0 plus means this is applicable. Right, root x, we are talking about root x. This is applicable. Obviously, root x it tends to 0. Right, limit x tends to 0. 0 plus root x. Obviously, the limit is 0. Okay. Now, limit x tends to 0 minus. This is important. This is good one. That means limit x tends to 0 minus. Uh, we have to find the limit for x square sine 1 by x. Okay, please notice sine 1 by x, whatever is x, will always range between minus 1 and 1. Okay, and there is a product of x square and sine 1 by x. What does that mean? X square into sine 1 by x, because sine 1 by x, 1 by x always ranges between minus 1 and 1. This will always be lying between minus x square and x square. Right, it will always be lying between minus x square and x square. And how does it look? Minus x square, the graph x square will look like this and minus x square will look like this. What does that mean? X square into sine 1 by x will always lie somewhere between this, between these two graphs, right? This one is x square, this one is minus x square, right? Because sine x 1 by x at max can go to 1 or at the lowest it can go to minus 1. So the product of this will always lie between either x square when sine 1 by x is going to 1 or minus x square when sine 1 by x is going to minus 1. So this graph will always lie between these two graphs. Now by using sandwich theorem, we can say because these two graphs x square and minus x square, as x is approaching 0 from this side, x is approaching 0, the limit of these graphs is actually 0. So obviously sine x square, sine 1 by x, because of the sandwich theorem, because this graph will always lie between these two graphs, and even though we cannot define exactly the value of this when x equal to 0, but the limit should be equal to limit of these two graphs. Limit of x tends to 0, x square, and limit of x tends to 0 minus x square. Right. Both of them, the limit is 0. So the limit of this function when x tends to 0 minus f of x is actually 0. Right. Let us take a few more questions. We know for a function a plus limit we know. Okay, whatever is the function a plus we limit we know, and limit a minus also at an interior point of the domain we know. Then do we exactly know what is limit x tends to f of x? We will know when this is equal to this. If this is L, a plus, and this is also L, a minus, then we can say yes, we know. And what is that value? That is L. If otherwise, if this is L and this is some P or something, then we don't know. Right? If you know that limit x tends to C exists, f of x exists, can you find it by calculating C plus? Yes, exactly. If it is C plus, if it exists, that means C plus limited C plus is equal to limited C minus is equal to limited C. Right? All three should be same. Right? So if you know that limit exists, and if you know what is the limit when x is coming to C plus, that is from the right hand side of C, then left hand side should also be equal to that, and limit is that whatever L. Okay, so we know this. Suppose that f is an odd function of x. Does knowing limit x tends to 0 plus f of x is equal to 3 tell you anything about limit x tends to 0 minus f of x? This is an odd function. What odd function, what does it mean? It is symmetric about origin. Right, x tends to 0 plus. That means we are moving from the right side. This graph is approaching 3. Okay, this graph is approaching 3. Now, obviously, because this graph would be symmetric and x is tending from 0 minus, this graph will approach minus 3. Right? Because this is an odd function. Please note, Odd function, here one is approaching plus 3, another is approaching minus 3. So limit x tends to 0 doesn't exist here. Okay. Now at the same time, you might get this confusion that here is an odd function. Earlier we discussed for odd function, because it is symmetric about origin. Does it mean that always this function should always pass through origin? Right. Odd function is symmetric about origin. What is the definition of odd function? As long as f of minus x is equal to minus of f of x for whatever x which is there in the domain of this function, then it is an odd function. This is the definition, right? F of minus x should be equal to minus of f of x. Now, if 0 is in the domain, if 0 is in the domain, then f of x has to be 0 for it to be odd function. Now, in this case, 0 is not even in the domain. Okay, because 0 is not even in the domain. That's why it is like this. Or if you want to say that 0 is in domain, artificially you will say f of 0 is equal to 0 to make this function complete. Okay, if 0 is not there in the domain, then also it can be odd function. So for example, lot of functions, right? Like this 1 by x. 1 by x is not defined at 0, but still it is an odd function, right? 1 by x. 1 by 0 is not defined, but still this graph is symmetrical to with this graph. 1 by minus x is equal to minus of 1 by x, which is f of minus x is equal to minus of f of x. Right? 0 is not there in the domain, but still it's an odd function. So x tends to 0 plus can be 3 and x tends to 0 minus can be minus 3, and still it's an odd function. Right? What we are just saying is this side of the graph it is approaching 3, then this side of the graph will approach minus 3. Right? That's what we are saying here. Okay, now suppose that f is an even function of x. Does knowing that limit x tends to 2 plus f of x equal to 7 tell you anything about limit x tends to minus 2 minus? Please be careful here. Here 2 minus. Okay, so there is a graph. There is a graph, let's say. Now, let's say this point is 2, 2 minus. That means we are approaching from the left hand side. Okay, this point is 7. Then anything about limit x tends to minus 2 minus. That means this point is minus 2 approaching from the left hand side. Can we say this point is exactly equal to 7? That is the question. If x tends to 2 minus, that means approaching from the left for this point 2, if this point is 7, approaching from the left of minus 2, can we say this point is also 7? Because the graph is symmetric. Okay, so this graph is symmetric, fine. But here we have to be little careful here. Okay, this graph, I'll make this symmetry little more. Okay, so let's say I draw the graph like this. Okay, this is symmetrical, that is fine. But let me extend the graph like this. Okay, now you are approaching from the left of minus 2. This is actually approaching infinity, minus infinity, right? This is one way of drawing this graph. Or otherwise, you can draw one more way like this. You can draw another way like this, a graph like this. Okay, or any other curve, whichever you want. Let's say you can make it a constant. You can make it a constant also, whichever way you want. Okay, if we make it a constant, then what does that mean? But still, this is still an even function because it is symmetric with respect to y-axis. Then, as you are approaching x from minus from the left hand side of minus 2, then this function, this value can be 2. This value can be 4 or whatsoever. So, it depends on what is this point when you are approaching from the right hand side, not from the left hand side, right? So does knowing that limit x tends to 2 minus, that means we know this point. Okay, so which means we know this point. So does it tell you anything about x tends to minus 2 minus? Minus 2 minus we don't know, but we know about minus 2 plus. Okay, if we know, please see this carefully. If you know what is happening as you move from the left towards this point 2, what that means is as we move from the right towards minus 2, we know this point. Okay, because this is symmetric, because this is symmetric with respect to y-axis, if you are moving from the left to this point, that means we know if the function is even when you move towards left from this point. So we know this point, but we cannot know this point, right? We cannot know this point. So to know, so this point we have to know, then that means we should know this one. What is happening if we are moving from the right? That and this will be same, right? So x tends to minus 2 plus. That is from the right hand side. Yes, this we know. When we know this, these are symmetric. These two we know. But this doesn't imply this. So minus 2 minus doesn't imply 2 minus. Right, minus 2 minus. That means if you want this, then what you need? You need 2 plus. Minus 2 minus, if you want to know what is happening here, we should know from the right what is happening here. So minus 2 minus and 2 plus are related. These two are related, and 2 minus, that is this one, and minus 2 plus. These are related. Okay, please be careful. Please understand this clearly. Right, guys? Hope you like this. Thank you.